Hey Mr. Mays, I'm going to be talking about circuits today. So first we have our diagram, and we have a battery here with a negative and a positive end, and it's got 20 volts, and this means that it has the potential to provide energy towards the circuit, and its max potential would be 20 volts. So here the lines represent wires, which are used to allow the charges to flow, and they get here, and then now we have a resistor, and the resistor basically is a alternative. It's like a impediment towards the charge getting from here to there, and what it does, it allows the charge to decrease, and it also like provides a path for it to follow, and then it continues here, and now it can either go to this resistor or that resistor, and I'll get into that more later. Then it comes down here to another resistor, and then it comes back to the negative end of the battery. Now batteries themselves can be organized either side by side like they're seen in remotes, or they can be organized like end to end. So we have another one here that would be positive and negative, and in this case you would add the two voltages, but in the side to side one it would remain the same voltage but just twice. So that would be treated as two separate systems. Now we have so now I'll get into resistors. So resistors can be one of two ways. The first one would be series, which is when it's like a continuous pathway when you aren't given a choice. Like if you want to think about it in layman's words, this would be the continuous one where you could come here, you have no other way to get to this side besides taking this path, and that's also the case here. But in a parallel one, you would have the choice of making either going this way or going that way. So what this means is when you want to find the total resistance of the circuit, the series are simple because that's the only pathway you can take. So you just have to add the two, so that would be 5. But then on the other hand, parallel is a little more complicated. You add the reciprocals of the two, and then you take the reciprocal of your final answer. So in this case it would be 1 over 4 plus 1 over 5, which gives you 9 over 20, and then the actual resistance would be 20 over 9. So when you add that 20 over 9 to the 2 and the 3, you're going to get 65 over 9, which also happens to be the answer to the first question. Total resistance, 65 over 9. Ohms would be the proper unit. Now next we have, we'll talk about the current. The current is what flows itself from here, so it's basically like the charges. And to find the current, you use the one of Ohm's law's equations, which the society itself calls it V equals IR, but as scientists, we know that I equals V over R would be the proper way to express it because it shows the true relationship between the variables. So to apply this, I is current, so that's what we're looking for. V is the voltage we have is 20, and then the total resistance we found was 65 over 9. So 20 over 65 over 9 would give you 180 over 65, which reduces to 36 over 13. And that's going to be in amperes. Now, the current itself is equivalent at the points of at the series, but in the parallels it breaks up according to proportions. So this question asks for the current at the first resistor, so here it would be 36 over 13 also because it is not a parallel junction, so it is just a continuous one. And then the last one asks for the voltage at resistor number 4, which is here. So voltage, as we know from Ohm's law, I equals V over R. We have the current, which is 36 over 13, equals V over 2. So we just multiply it over, we get 72 over 13 volts. That's how you should approach these circuit problems. You want to draw the diagram in a way that it's the battery goes to a resistor. If there's any parallels, you want to draw them like this so it's easier to comprehend them. Then it goes back to a resistor and comes back to the negative end. Now we also have Kirchhoff's laws, which assist us in solving these type of questions. So his first law is that current flowing in to a loop must equal the current flowing out. So what that means is the current here is going to equal the current here, which, like I said, it has to because of the series. That's based on his law. And also, his second law was that the voltage provided by the battery, 20 volts, has to equal the sum of the individual voltages at each resistor. So the 72 over 13 here has to be added with another 3 to equal 20. And then also something useful to know would be Joule's laws, which are used for power. And those are P equals I squared R, which is current squared times resistance. P equals current times voltage, or P equals voltage squared divided by resistance, where P is power. And then now for the analogy, we have, so I thought that circuits were kind of like a highway if you think about it, because on the highway you're on like a continuous road like that you have to travel on. You don't have a choice unless you take like inner roads to get to your destination. So the circuit's like a highway where the positive end, or one way to enter, would be like your first exit that you took to get in, and then your exit point would be the point you took to get out. So in that case, the current would be like the cars, the stuff that's actually being transported. The wires would be like the roads, because that's what you're moving on. I thought the voltage would kind of be like the fuel that powers the cars, because as Mr. Maze's monkey example, just because Mr. Maze can be a monkey on a roof does not mean that he is at this moment. It's his potential. So the same way, the fuel is in the car at all times, but it's not, the car won't move unless you apply the fuel. So in that case, it would be like the voltage offering a potential difference. And then lastly, I thought the resistor would be kind of like a detour, because detours usually end up taking more time, which makes things more unpleasant and takes away from your trip, which is like what resistors do. They take away energy. And also, detours offer like multiple paths to get somewhere. And I think that's it. Thank you.